rewrite each of the following equations. Rewrite 5 to the 5th is 3125 as a log equation. So what do they want me to do? So let's take part A down here. So we have 5 to the 5th power is 3125. They want me to write it as a log. They want a log in there somehow. The main point of this example is that logs and exponentials are inverses of each other. So they cancel each other out, kind of like square root of x and x squared are inverses, right? Those are inverses, so that if you're trying to solve an equation like x squared is 9, you know what you do. You root both sides and it cancels it out and you just have x and it's 3, right? The root cancels out the 2 power because they're inverses. Well, that's what we do here. If you want to get rid of this, if you want to change the form, you put a log on both sides. Specifically, let me be a little more specific. Every log has a base. So you put log of the same base, log base 5 and log base 5. You do it just like that, log base 5 both sides, and these guys will cancel each other out when the bases match like that. And so we just have this other 5 left over is log base 5 of 3125. So there's part A. That's what they want you to write right here on this line. 5 equals log base 5 of 3125. And then the second one, part B, they want us, this time we do the opposite. We start with a log, and we want to rewrite it as an exponential, meaning we're gonna lose the log. Well, how are we gonna lose the log? Well, what's the opposite of a log? An exponential. Now wait a minute. I don't see a base on this one. Didn't I just say back here, every log has a base? If it's not showing its base, do you know what it is? It's 10. It's the understood invisible base for a log. If the word log is not showing its base, it's 10. Okay, so now what do? We have to make the same base, 10, on both sides, and then these cancel each other out. When the base of the log and the base you're using are the same, just like here, the base of the log and the base of the power are the same, they cancel. The base of the power and the base of the log, they cancel. They're opposites, like a square root and a second power. So what do we have left? Just 0.001 equals 10 to the minus third. There we go. That's all they want on this one. They want us to say the same thing in a different language. I hope you understand that. It's like saying one or uno. You're saying the same number, just in two different languages. Well, that's what we're doing here. When we say this or we say this, we're saying the same thing. This in the log language, this in the power language. Same thing here. This in the log language, this in the power language. They're the same two statements in different languages. That's what we're practicing doing. How do you change between the languages? You remember that they're inverses of each other. So if you have powers with no log, you log the same base as the base that's already there on both sides, and they cancel. Or if you have a log already there with a base, you do the same base on both sides, and they cancel. Logs and powers are the opposites as long as the bases match.